on what was a tennis court that no more than 4 kids could play on at any one time. Seattle has something, check this out. Go to a website and look up street edge alternatives, C streets. So here's a street, really straight, cars go fast, storm drains failing, parking's really bad, no sidewalks. Mom ain't letting the kids play in the street, they're going to get run over. All right, so if you keep your eye on that building, same one. They're putting the curbs back in, they're getting parking, and they got rid of the paving, piping, polluting, and it's 100% on-site recharge. Right? They're catching the water and slowing it down. Here's an aerial photo. They're putting little wiggly wigglies in the street. Form follows function. Traffic calming, slowing, increased parking, stormwater, 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 green space, sidewalks, safer streets, and the value of those homes are up 30% on the market from the adjacent neighborhood that didn't get the retrofit. Just by wiggling the streets and doing stormwater and greening. The real estate agents are super happy about this right now. Right? This multiple benefit concept. And just a couple thoughts for you here in the LA watershed basin area. The work of tree people in collaboration with a number of agencies in LA County and city and such. Any tree people folks in the house here? All right. Well, in the Sun Valley watershed is one that Andy lived in, and they had lots of flooding, and so Army Corps said, well, we'll put a pipe, we'll make it go away. It'll cost you $40-60 million bucks. And a bunch of folks came together and said, I don't think so. Why not invest let's spend $100 million bucks up front, right? Instead of 60. And we're going to get some new ball fields, and we're going to improve the existing ball fields. And we're going to retrofit this and work on daylight and creeks and green space. And we're going to catch that stormwater, reduce the flooding, put it in the ground for local water supply for the future, and in the process, basically save, the estimate I've heard him talk about is up to $400 million over the next 20 years. If you count all of the benefits of water supply and flooding and open space and community health and air quality. So they took ball fields up, and underneath now are these chambers, and then the ball field goes back on top. And you've got stormwater chambers that catch the surface flow, cool it up, and in this case, my understanding is it's able to actually infiltrate into the groundwater. I don't know about, my understanding is Compton Creek has less connectivity with the geology of how to get to the groundwater basin, but that's something to look at. So how do we do that? And as far as I can tell, this is just a map I pulled off. The tree people folks up, say, San Fernando Valley area have got just tons of these projects, and you should check it out. And they're, as far as I can tell, when I search the nation, they're leading the way on this kind of stuff. And so you've got to figure it out with this. And this is your totem species, if you will. This is your totem opportunity to come together to craft a vision for how this channel can be something that performs in a way that you all like. And how do you move from this trapezoidal shape? Maybe you don't get to make it into a more of a shape that has a low flow channel and flood channels and allows for vegetation and things like a cross section of a more typical creek might look like. But maybe you can get that system to at least take the straight line and begin to provide some greater performance and function within the stream. And probably never going to get Compton Creek to go back to looking like that. Although I'll bet a lot of it did, because we're in the flat bottom part of it, a big wiggly stream. Lots of resources out there. There's a great friend of mine, Ann Riley, who's up in the Regional 2 Water Quality Control Board, this book, Restoring Streams in Cities. She has a DVD, Urban Stream Restoration. Some of you, the more wonky types might want to have a peek at. But lots of booklets out there, lots of stuff on there, and lots of folks doing this work, basically. I was looking at this up in Bremerton, Washington, a community process where they're redesigning a section of creek, and you can't read the slide, but a lot of it was about native vegetation and stormwater and access to the creek edge and habitat and water quality, in their case salmon restoration, and then fronting economic development on that to improve the overall desirability of that portion of the city to attract folks to spend money there. Up in Santa Rosa, we had a trapezoidal streamlined channel there in the city of Santa Rosa, and This is a look at how they reworked that channel. There's still some hard edges to it and some banks. They were able to open it up, get a sinuous channel back that has natural gravel bar forming processes and pools, revegetate it, and still keep the flood control folks happy as far as the, what's called the cross-sectional area, the conveyance capacity of the channel. And it's got lots of bike ways on it and opportunities for kids to play in it and that kind of stuff. Napa River, you might have been tracking, they get a lot of airplay on this too. Napa had significant flooding, and they had just kept channelizing the Napa River, and it was not working. And they finally looked and said, we've got to find some place to move the water. And through a major process, sounds similar to what happened here with watershed planning processes and corridor planning processes, they figured out places to actually break the levees out and push them much further back and allow areas to begin to re-flood places that they used to flood. But what I mostly like, and I just pulled this off one of the reports, is that they had a set of goals and objectives for their group that when they sat down, they agreed that they wanted a living river system. That was their first primary goal. And then it was that it was based on geomorphic. Geo is geology, morphic is shape. So what was the shape of the channel and how the flow would work? Water quality and habitat. And they led with those things. Not that they were doing that to the exclusion of the economic interests, but that the economic interests got clear that if they got that stuff right, that the behavior of the system would create conditions conducive for a better economic setup. So it wasn't that they were not leading with that side of things. And they've done a whole bunch of stuff. Here's the parking lot with the linear livers in it and porous pavement, and they've got areas they opened up and lots of stuff. And now this is part of the Napa River Walk, you might call it. And they brought social focus into there and a place for gathering, and they brought the community to the edge of the river to face the river and honor that interface where the land and the water meets as an amenity versus something to hide behind a fence. I was looking at this one recently up in Pueblo, Colorado, and it's just an interesting design of how they work their river system, and lots of pools and islands and crenellated little wiggly edges and lots of interface, lots of green space, lots of what we call ecotones or edges. The more edges they could connect, the more surface area you could have access to. San Antonio Riverwalk got mentioned. It's, as many know, it's a highly coveted spot there in San Antonio. The thing that is pretty clear that the challenge y'all face is, many of these pictures like, well, that's quaint if you've got a year-round river type system that's got water you can float boats on. That isn't the behavior of Compton Creek, so you're going to have to design something else. So it's not like these are not going to get to replicate this, isn't my point in showing you these images, but mostly to just offer up the creativity of communities who face these challenges and design something that worked for everybody. I was looking a lot up in San Fernando Valley. There's just a ton of projects going on upstream of the Los Angeles River there. Again, you'll see infiltration stuff and natural habitat and edges and built environment. And how do we begin to just soften this interface is what I think lots of folks are looking at. And it's got to be a community-based process. I was talking to Alex last night about our school garden future trainings, and every school garden that's been put in a school where somebody just parachuted in, dropped the garden in, hired contractors, paid for it, installed it, and the kids show up on Monday morning to a new garden, that thing gets trashed and tagged and graffitied and worked over. Every school garden that we've ever done where the kids and the parents are involved in the design, the development, the installation, the maintenance, the harvest, those schools they continue, they still have challenges, but they're part of the community. So I'm really excited to see all of you here being a part of the process versus a part from the process.